We'll show you how to use closures to encapsulate some information as private variables. This will help you write better, cleaner code. Unlike most other object-oriented languages, JavaScript does not support traditional private variables, that is, object properties hidden from outside of the object. This is where closures jump in. Let's take a look at the following code example. We have a constructor function ninja, which means that if we invoke it with the keyword new, a new object instance will be created. Next, when we enter the constructor, a new scope is created and we define a variable feints that will hold some private state. The JavaScript scoping rules limit the visibility of this variable to within the constructor. To give access to the value of the variable from code that's outside the scope, we define an accessor method, getFeints, which can be used to read but not to write to the private variable. We also create a method feint, which gives us control over the value of the variable in a controlled fashion. After the constructor has been defined, we can use it to create new objects. And we can call methods on the newly created object. Finally, we can test that we can use the accessor method to obtain the value of the private variable, but that we cannot access it directly. This effectively prevents us from being able to make uncontrolled changes to the value of the variable, just as if it were a private variable in other object-oriented languages. Every time we call the Ninja constructor, two new anonymous functions with closures are created that protect the variables that are currently in scope. So even though the constructor function has returned, our two methods keep alive our private variable feint. We can access the variable only through these two methods and not directly. Remember that a new function scope is created each time a constructor is invoked. This means that if we change the code a bit by creating a new Ninja object and adding tests for it, we'll have the following situation. When we create the first Ninja object in the constructor, within the new scope we create a local variable feints and two functions that will be closures around the local variable. The two functions will be assigned as properties of the newly created object. Now, when we call the feint method on that object, we increment the local variable because it is accessible through the closure. Next, when we create the second Ninja object, a new local variable is created along with two new function closures that will be assigned as object properties. Notice how each Ninja instance, through closures of its methods, has access to its own local variable feints. So it's not really that we're creating private object properties, but more that we're mimicking them through method closures. However, this holds only for methods created within constructors. For example, take a look at the following code, in which we create a new object method outside of the constructor. This new method is created in a scope different from the getFeints and feint methods, and thus does not have access to the feints variable.